Hi guys. Okay, we're going to graph the entire quadratic equation here in lesson 8.3. So we're pulling in all of the variables. And I just want to take a quick moment to think back to like linear equations. If I gave you something like y equals 3x plus 1, we know that's mx plus b. So 3 is my m value. 1 is my b value. This is a good little review, real fast, obviously. And we learned how to do this, right? So we start with the b, the y-intercept, and then we do our slope, which is rise, 1, 2, 3, over run. Or we could go down 3 into the left one, and that makes our equation. Now, the other way we could have graphed this, this linear equation, is we could have made a table. Okay, that's really how we started doing this. We would do -2, -1, 0, 1, 2. That's how we started linear equations on their own, right? We started with a table, and then we learned some of the intricacies like we have here. Well, similarly, what we're doing now is that we started by making a table for quadratics. That's what we did in lessons 8.1 and 8.2. And now we're going to go ahead and learn some like key factor ways of graphing these quadratics, okay? So one thing you may be noticing is that there's a b in here, so that's going to change something. So right now, let's just take a look at what that changes. So if I have this Desmos function, okay, so we already learned what a does. A makes it narrower, wider, vertical stretch or shrink, and it reflects the graph if needed. Okay, so let's put that back just to 1. We already learned what c does. C moves the graph up and down, right? Now, if I put that just at 0 for the time being, let's see what b does. And maybe you've tried this on your own, maybe not. But b is going to move the graph to the left and the right, okay? So as I start to move these things, all of them, I can start to get things that look they're all over the place, okay? Alrighty, so now what our goal is in this lesson is that we're going to go ahead and figure out how to graph that, okay? And to do that, let me just show you one more thing to bring it together. I have here written a quadratic equation, okay? And I made a table, just like we've done all chapters so far, -2, -1, 0, 1, 2. But I'd like you to look at, I already filled this in for you just to save time. Let's look at our y values, like my outputs. So what do you notice? Do you see anything there? We have -9, -7, -1, 9, and 23. Are these symmetric? Aren't they supposed to be the same? Like, aren't they supposed to be the same number? And that's not the case here. So we run into a little bit of a problem. Now, it makes sense. I actually graphed it down below and took a screenshot of it. Look, this graph here isn't right around, it's not symmetric about the y-axis like all the ones we've done before. And the reason is because there's a b value. That 8x, that b value of 8, throws the graph, it shifted it, okay? So it's over here. So it moved it a little bit. So the problem we run into is when we have an A, a B, and a C, most particularly when we have a B value, we can't just make a table like this because these numbers aren't going to be symmetric. Sometimes you'll make a table and you'll go to graph it, and all it will do will give you like points that look like this, which hardly look like a parabola. And then you don't know how far does it go. It doesn't give you enough of the picture. Okay, so that's why this lesson is going to look a little different than others, but it's important because we're going to learn some key things to focus on. All right, so here are some core concepts. First of all, we've already talked about this. If it's a is greater than 0, if this first number is positive, it's going to be looking like that. We called it a smiley face. And if this first number a value is less than 0, if it's negative, then we have a parabola that looks like this. I kind of think of it as like a negative sign is frowning, okay? All right, the next thing that we're going to focus on just for right now is this here, this axis of symmetry. Now we understand what it is. It's always that point, that line where my graph is symmetric about on both sides, right? It's equidistant to both sides all the way through. So it's symmetric there. But what's different now is that for everyone we did in lesson 8.1 and 8.2, where we were actually graphing them ourselves, they were always symmetric about the y-axis. They were always like this, or maybe they even were upside down. But they were always symmetric about the y-axis. Well, not so much anymore. Now, like we saw in Desmos, it shifts it left and right. So this is important now what we're going to do is our first step, step 1, is going to be to go ahead and find the axis of symmetry, because that gives us a starting point. Okay, so let's go ahead. We're going to try these 3 down below, well, these 4 rather. We're going to do this for this one, and then 1, 2, and 3. And we're going to just find the axis of symmetry, the first thing they're asking. Okay, so the axis of symmetry is given to us as negative b over 2a. And you might be thinking, I kind of remember that. Negative b plus or minus the square root of b squared minus 4ac all over 2a, right? If I get rid of, I was forgetting the sing-song for a minute. If I get rid of all that, isn't that what we have here? It is. Okay, so it's easy to memorize, negative b over 2a. It's a lot shorter. And I'll explain later as to why we can kind of just dodge that and why this equation is what it is. It gets into some calc things, and there's other ways, but there I saw one really nice explanation. Anyways, let's try this first example 1. So my a value here is 2, my b value is 8, and my c value is negative 1. Okay? All right, so my axis of symmetry is always x equals negative b over 2a. So in this case, it's going to be negative 8 over 2 times 2. So negative 8 over 4, which is negative 2. So my axis of symmetry is x equals negative 2. Okay? Now they're not asking us to graph this, but all that would mean is if I were to just kind of get a mental sketch, if I would sketch in a dotted line at negative 2, my parabola is symmetric about that line. Okay? We don't know anything else about it yet. That we're going to be talking about, but it would be symmetric there, okay? The only other thing I could say is that because this is a 2, it's going to be facing up like that. Open up is what they call it. All right, but let's make practice with some more axis of symmetries. So for each of these 3, there's 2 parts. A is find the axis of symmetry, so let's do that first. All right, my a value, my b value, and my c value. I'm just going to list those so we're clear. My a is 3. My b is negative 2, and my c doesn't exist. Okay, now it really doesn't matter here because c is not part of this formula, but negative b over 2a is actually going to be negative 2 over 2 times 3, which gives me x equals 4 over 6, or 2/3. Oh, how did I get 4? Sorry, I think I was multiplying something and it didn't exist. It's going to give me, 2 over 6, 1/3. Okay, so that's the answer. Sorry, thanks for catching that if you were a step ahead. All right, now let's try number 2. My a value here is 1, my b value is 6, and my c value is 5. So when I put these together, x equals negative b over 2a, which is going to be negative 6 over 2 times 1. So x equals negative 3. All right, that's my axis of symmetry for that one. And there was that first one. All right, the last one. My a value is negative 1/2. My b value is 7. And my c value is negative 4. Putting that together, x equals negative b over 2a, which is negative 7 over 2 times negative 1/2. So I end up getting x equals negative 7 over negative 1, because that's half of 2 is 1, but it was a negative. So that gives me negative 1. And then negative 7 over negative 1 is just 7. So here it's x equals 7. Okay, so that's the first part of these. And that's the first step you can always do. Again, this is because we can't just fall back on a table. Now that there's a b value, it moves the graph. So we had to figure out what our first starting point is. All right, and we did that. We found our axis of symmetries. Now, the next step, let's clear out some of this stuff so it doesn't look so messy. All right, so step 1, we said, find the axis of symmetry. Step 2 is to find the vertex, okay? All right, so let's think about this. If we know that this is where my parabola is symmetric over, and we know that there is a vertex that's either the most bottom point or the top point, and it falls on that axis of symmetry. Well, this is my x coordinate. That's why it says x equals. So whatever this vertex is, that ordered pair is going to be we know it's xy, but since x is on the axis of symmetry, it's negative b over 2a, and then whatever the y value is. So what I'm saying here, and that seems like a lot of letters, so let's let that set in for a minute. The short answer is that once you find your x equals negative b over 2a, once you find your axis of symmetry, then you're going to substitute that in for x and solve for y. So let's try it, okay? Nothing's better than actually trying it out, working it through. So we found, let's try this example one. We found this axis of symmetry. We said it's x equals negative 2, right? If I clear all that out, my equation is f of x equals all of that there. So since I know that x equals negative 2, I'm going to substitute negative 2 in for every x that I see. Okay, and if you remember function notation, we write it like this. Let's erase this graph too so we don't feel confined. When we write it, we say f of negative 2 equals 2 times negative 2 squared plus 8 times negative 2 minus 1. So notice everywhere there was an x, even in the function notation, I've replaced that with negative 2, negative 2, negative 2. Okay? Everything else stayed exactly the same. All right, now this first part, f of negative 2, that's just notation. That does not change. When we first learned that, we said that we have to keep that together. That is like a clump. It does not move. It's called f of negative 2. We just write it like that. I'm not multiplying them. I'm not going to divide. It's just a clump. It's notation. But this part here, I can go to simplify. So doing exponents first, negative 2 squared is going to give me 4. Now I have 2 times 4. Now 8 times negative 2 is negative 16 minus 1. All right, continuing that further, 2 times 4 is 8. 8 minus 16 minus 1. 8 minus 16 is negative 8 minus 1, and I get negative 9. So my answer is f of 2 equals negative 9. Okay? Well, that might not seem like much, and maybe it's going back in your brain a little bit, but let me rewrite it. So f of negative 2 equals negative 9. We want to remember that f of x, whatever they write, it's just another way of saying y. They're exactly the same thing. It's just a different method of referencing it. So this is my x value, and this is my y value. They go right together one for one. So the ordered pair that represents my vertex is going to be negative 2, negative 9. Okay? All right, and I actually graphed it. Like I said, I graphed this on the next page. So let's just see. If I go ahead, this point right here, even though it's not marked, this is negative 2, negative 9. That's the vertex. Okay, so this is what our graph ends up looking like. And we haven't learned fully how to graph it yet, but we have learned that we have an axis of symmetry at negative 2, x equals negative 2. We knew that it was open up, a smiley face, and we now know the vertex here is at negative 2, negative 9. So we're learning pieces of the puzzle that are going to help us start to sketch the graph. Okay? All right. I'm going to go through and just keep working. So now on these bottom ones, there's a lot here. It was 1/3, negative 3, and 7. X equals 1/3, x equals negative 3, and x equals 7. So first step always to find your axis of symmetry. And to do that, you do x equals negative b over 2a. Your second step, in order to find the vertex, is you go ahead and substitute. Oh, I think I spelled that wrong. Substitute x into the equation or the function, depending on what you're working with. An equation is when you have y, a function is when you have f of x. No big deal. So for right now. So substitute x into the equation, and that gives you your point. Okay? Now I'm going to stop there, but I am going to make another video right now just to go through these last 3 and then do one more together with you all together. Okay? So visit that if you're still having questions. It's going to get a little more involved, so don't Don't skip it if you're a little confused, or come see me. Thanks, guys.